Hello, I'm Dr. Hassan Tohid once again with a sensational topic as usual, systematic review versus meta-analysis. Systematic reviews versus meta-analysis. What exactly is the difference? There are so many students who are learning it for the first time. They get confused between the differences when we talk about systematic review versus meta-analysis. So in this video, I will talk about the differences. So what exactly is the difference? First of all, we need to understand what is a systematic review. Remember, systematic review is a review article which is written systematically. That means we combine previously published papers and some unpublished papers, some gray literature. We combine them together systematically and we write a paper. Once we write that paper, this is known as systematic review. Now, what is a meta-analysis? Meta-analysis is also exactly the same thing. So yes, I know you are confused now. Let's talk about this now. Remember, meta-analysis is not a separate study design, to be very honest. Meta-analysis is an optional component of a systematic review. A systematic review becomes a meta-analysis. Yes, let me repeat again. Meta-analysis is an optional component of a systematic review. Yes, a systematic review can become a meta-analysis. All the meta-analyses are actually systematic reviews first. But not all systematic reviews can become meta-analysis. Just like a difference between somebody who has done master's and somebody who has done PhD. You cannot directly do PhD. You have to go through bachelor's and master's first, right? The same thing here. You can consider systematic review as master's or bachelor's and meta-analysis as PhD. That every meta-analysis is actually a systematic review, but not all systematic reviews will become meta-analysis. Like not all master's and bachelor students will go on to PhD. So this is a best example I can give to make sure that you understand the difference. Now, when you write a systematic review, how do you write it? You collect papers from previously published sources. You follow PRISMA checklist, preferred reporting items for systematic reviews and meta-analysis. PRISMA stands for preferred reporting items for systematic reviews and meta-analysis. PRISMA checklist. Once you follow this, and as you see in the name, there is a name meta-analysis mentioned in PRISMA. MA in PRISMA is meta-analysis. So actually the same checklist is for systematic reviews and meta-analysis. So they are actually the same design. So you follow PRISMA checklist and you collect data according to PRISMA checklist and you write a paper that is a systematic review. And meta-analysis is an extension. Now, let's talk about the phases quickly of systematic review. Systematic review has the phase one, that's the stage one. That's the planning stage where you plan your systematic review. You plan your research question, you plan your topic, you plan your research question, you have your inclusion exclusion criteria ready. And you also do the registration if needed on Prospero. And once you have done it, your systematic review, stage one or phase one is ready. Then you go to the phase two, that's the search strategy phase. Now you will search different databases like PubMed, PubMed Central, Web of Science, Scopus, and you will search your data on those databases. If you're using PubMed, you will use mesh strategy and regular keywords. But if you are using other databases, you will just use regular keywords. So you decide your keywords and you search data. When you have searched your data, now you will remove duplicates. When you have removed duplicates from your study, now you do the screening. First screening will be the screening of titles and abstracts. The second screening will be of the full text. Once you are done with that, and remember, 2 people will do that. Once you're done with that, what will happen? The next thing is that you will check the quality of the studies that you have kept. Once you have checked the quality of the studies, now you have the final number of studies left. Now you do the data extraction using the data extraction form. And then the phase 3, the stage 3 is the writing phase, and you write your systematic review. So this is how a systematic review is done. But in meta-analysis, there is an extra phase before writing. That is the actual meta-analysis phase, the actual statistical data analysis phase. So what do we do? Yes, the first phase is the same. Second phase is the same. Now, the third phase is the meta-analysis phase. What do we do here? We do statistical data analysis, but first we need to define or decide what kind of statistical model we will use to conduct our meta-analysis. Yes, there are 2 famous models, random effects model and fixed effects model. So which one is the best? Remember, we cannot say which one is best. It depends, because in fixed effect model, we assume that there is a true effect, that all the studies, the intervention that is mentioned in all the studies actually has the effect that is showing as the same effect, or you can say there is a true effect. Let me give you an example. Let's say there is a medication you are studying isoniazid, right? That's one of the most common examples I give. So isoniazid, right? Let's say you are looking at isoniazid's effect on certain people. So now you assume in fixed effect model that this medication will have the same effect on every single person. In reality, or the reality is that it is not possible. The same drug will affect differently, will have a different effect on different people. So that's the difference in reality, right? So in fixed effect model, we assume that yes, there is a true effect. So if we assume that, we can use fixed effects model. This is a statistical model. There is a process, and we will talk about fixed effects model in one of the videos. Now, the second assumption is random effects model. That means this is another way of doing meta-analysis. Random effects model assumes that there is no true effect. That means there is heterogeneity. That means there is a difference. The drug is not affecting in the same way on each person. So which one is more closer to reality? Random effects model. So that's why many scientists accept random effects model as the best model to conduct a meta-analysis. So once you choose random effects or fixed effects model, it's up to you and you follow it. By the way, we assume that the results will be same. If we choose random effects or we choose fixed effects model, the results should be same. But unfortunately, this is not true. Some studies have shown that actually the results are really different. And only few studies will show the same results. Only 10-20%, I would say. 20% studies will show the same results, but most of the studies will show different results if you choose a random effects model or fixed effect model. So you have to decide wisely which model you will use, and you decide with your team. And then once you finalize it, and what do? You do the forest plot to find the heterogeneity. Once you do the forest plot, the next step is the funnel plot. You check the publication bias. Once you have the funnel plot done, what's next? You do the bubble plot. Once that is done, now your statistical data analysis is done. Now you have analyzed everything. What exactly have you done here with this analysis? You have combined the results of each study that was included. Let's say there were 10 studies included in your systematic review, and these studies were similar. Only then you do a meta-analysis. So if these studies are similar enough to be combined together, then you can do meta-analysis. So let's say these studies are similar. Let's say there are 10 studies. Look at my hands, okay? These are 10 studies. Each study is talking about isoniazid and its effect on skin. And all of these studies are similar, with similar intervention and similar outcome. Maybe a little bit differences in the dosage or in the dosage. So let's say these 10 studies, can we combine them? Absolutely, they are combinable. So yes, then this systematic review will have to become a meta-analysis. So you cannot just keep it as it is. You cannot just write a systematic review and leave it. Now you have an opportunity to convert it into a meta-analysis. Remember, meta-analysis is an optional component of a systematic review. So now it's up to you. You combine them together. How? You will look at the results of each of these studies and you will add them together, combine them together. There's one way of doing it, like doing the mean, right? But it is not the best way. That's why you have to do statistical data analysis of random effects model or fixed effects model. And then you follow all procedures. And when you have the combined results, now you begin writing. So this is how a meta-analysis is written. So exactly what is the difference? Remember, in systematic review, become meta-analysis if you have similar studies. And you will have to do meta-analysis by choosing fixed or random effects model. If studies are different, now you cannot combine. Let's say some studies have a different outcome. Some studies are talking about the skin problems. Some are talking about bone problems. Some are talking about nerve problems, X, Y, Z, whatever. So can you combine them? Not easily. So these are not combinable. Now it will remain a systematic review. So remember, if the studies are combinable, it will go and become a meta-analysis. If the studies are not combinable, you cannot convert that into meta-analysis. It will remain a systematic review. So if studies are different, we cannot combine them, what do we call them? We call the situation as heterogeneity. These are not homogeneous studies. These are heterogeneous studies. You cannot combine them. That's why it will remain a systematic review. So you will have just 3 phases. Phase 1, planning phase, then the search strategy phase, then the writing phase. And this is a systematic review because you had heterogeneous studies, different studies. But if you have combinable studies, you have similar studies, now you have an opportunity to convert your systematic review into meta-analysis, because remember, it's an optional component of meta-analysis. And if you have combinable studies, ideally you should do meta-analysis, because reviewers will ask you this question, why you did not go to a meta-analysis when you had similar studies? And you will have no reason to tell them why you didn't do it. So just go ahead and do that. And don't worry about it. It's not that difficult. It's easy. You just need to know how it is done. So once you have similar studies, now you don't jump to the stage 3 after stage 2. or phase 3 after phase 2. You have an extra phase 3 that will be the actual meta-analysis by choosing which statistical model you will use. And once you do it, then you begin writing, and that will be your meta-analysis. Now, meta-analysis can be done manually, but usually it is done by software. It will make things easier for you. What softwares are most common? Review Manager, RavMan, that's one of the most common ones, and Stata. Stata is a good software. R software, R language. So these are the commonly used softwares for meta-analysis. So remember, in systematic review, you don't need meta-analysis. You don't need statistical data analysis of that extent where you have to do data analysis by a software. Systematic review can be qualitative. Systematic review just qualitative. You describe a narrative summary, and that will be your whole paper. But the moment you have similar studies, you will change it to a meta-analysis. So that's the main difference. So actually, in reality, there was no difference. And this video title was a misnomer. I would say a confusing title where somebody who knows research would say that actually there is no difference. Systematic reviews become meta-analysis. So yes, that's true. So I'll repeat again in the end. The summary is systematic reviews and meta-analysis. What are the differences? Actually, there is no difference because systematic reviews will become meta-analysis. If you have similar studies, then your systematic review will not remain qualitative, will not remain narrative. You will have to do data analysis, statistical data analysis using a software, and your systematic review will become meta-analysis. And in meta-analysis, you have two models of statistics: fixed effect model, random effects model. So fixed effects model, random effects model, which one you use? Mostly random effects model because it is closer to reality. That's what you can say. So once you do that, once you follow, now the next step is that you draw the forest plot, the funnel plot, the bubble plot. Once that is done, your statistical data analysis is done. That means you have combined the results of all the studies, because meta-analysis is actually the pooling of all the results together. Remember, in systematic reviews, you were just combining studies together and you were writing a narrative summary of all the results together. But here you are adding the numbers. Here it's quantitative. That's why you do statistical data analysis, and that's called meta-analysis. And you use a software mostly to do that. Most commonly used softwares are Stata, RavMan, Review Manager, and R language. So these are the most commonly used softwares, and this is how meta-analysis is done, and this is how systematic review becomes a meta-analysis. So in reality, there is no difference at all. Now watch this video again, take notes, listen to this video again, play it again and again until you are really confident that yes, you do now understand what exactly is meta-analysis and what exactly is systematic review. And comment any questions you have, and I'll get back to you as soon as I can. Now keep learning and keep watching. Thank you.